Hello, my name is Luis Murillo. I'm gonna talk about Gigabit digital isolators for video converters communication. Some reason for isolating. Some reasons for isolating are safety, functionality between different grounds, reference, protection from common mode transients, elimination of ground loops, confinement of electrical noise. What is a digital isolator? These digital isolators isolate digital signal and barrier transfer digital communication across a barrier between microprocessors and data converters. Now I present a video about digital isolators.
In the iCoupler Digital Isolator Group, we are striving to redefine the boundaries of product performance. We are now introducing the ADUM 144X family of ultra-low power digital isolators. This chart shows the typical power consumption of isolators across different technologies. The optocoupler at 40 milliwatts per channel, capacitive isolators at 13 milliwatts per channel, then ADI's inductive technology at 2.3 milliwatts per channel. And now, the new ADUM 144X family with power so low it doesn't even show up on the chart. It draws quiescent current of 18.5 microwatts per channel with refresh enabled, and an astounding 3.3 microwatts per channel with refresh disabled. The new ADUM 144X family uses so little power that it can be powered by, well, let me show you. Until now, signal isolation was the most power-intensive function in many applications. But the new ADUM 144X family uses so little power that it can be powered by a potato. It's the world's first potato-compatible isolator. Let's see it work. I add the electrodes to our green battery. I have a 50 kilohertz input signal here on the scope screen. As I make the final connection to the potato, the data comes flying through. For those designers not ready to make the organic plunge, you can use the ADUM 144X family in more traditional applications where ultra-low power would be of benefit, like 4 to 20 milliamp industrial buses and battery-powered devices that have to operate for long periods of time in the background. For example, this little coin cell has enough capacity to run this isolator for about 43,000 hours. The ADUM 144X family comes in multiple channel directions, is capable of up to 2,500 volts of isolation in an ultra-small QSOP package, and it supports 2.5 volt and 3.3 volt supplies. It has all the reliability of the first generation of iCoupler digital isolators, but with much lower power consumption, especially at low frequencies. If you do go the green energy route, you get other perks as well. When you're done powering your device, you can eat the battery. For more information on the 144X family, including datasheets, evaluation boards, and samples, please visit www.analog.com/ADUM144X.
This video has not been endorsed by the National Potato Commission or any of its associated agencies.
How does a digital isolator work? Well, a signal or logic input indicates a digital state. Then the signal passes from modulator and a high frequency signal converted and passed through isolation capacitor. Then the signal passes for a demodulator, and the signal demodulated input signal reconstructed and output with minimal time delay. The difference between an optocoupler and digital isolator. An optocoupler is an hybrid device that uses LED light to transmit data across an isolation barrier to a light detector. The LED turns on for logic high and off for logic low. Optocouplers consume high levels of power, are prone to aging and temperature effect, and provide limited data rates, often below 1 megabit per second. The digital isolation device uses semiconductor process technology to create either transformers or capacitors to transfer data instead of light. With this technology, performance and future integration are both improved. Now I present a video about optocouplers versus digital isolator.
Hello, I'm Phil Cowden, Marketing Manager for Silicon Labs Isopro Digital Isolation Products. Over the past 40 years, the optocoupler has been the default signal isolation device. However, recent breakthroughs in silicon isolation technology are changing the game, enabling smaller, faster, more reliable, and more cost-effective solutions than that of the legacy optocoupler. Industrial equipment must operate in the harshest of environments, which presents challenges when designing isolation circuits, which must deliver error-free operation over long equipment lifetimes. Digital isolation technology is better able to address these challenges than what we've used in the past. But how does it work? Figure 1 shows top-level block diagrams of an optocoupler and then Silicon Labs Isopro digital isolator. The optocoupler is a hybrid assembly with an LED that emits light with forward bias, with brightness being proportional to the LED forward current. Emitted light passes through an optically transparent insulating film, striking a photodetector and causing a current flow that biases the output transistor on. When LED forward current no longer flows, light emission ceases and the output transistor turns off. The basic operation of an Isopro digital isolator is analogous to that of an optocoupler, except that an RF carrier is used instead of light. The patented approach consists of two identical semiconductors connected together within a standard IC package, forming an RF transmitter and receiver separated by a differential capacitive isolation grid. Data is transferred from input to output using simple on-off keying. Unlike the optocoupler, each isopro channel occupies little data area, making possible cost-effective, high channel count solutions. Additionally, monolithic semiconductor process technology enables isopro technology to be combined with other semiconductor functions and processes to create highly integrated products with built-in isolation, such as isolated analog data converters and communications transceivers. These integration advantages enable a broader and comprehensive product rendering the legacy market. The history of the semiconductor industry has shown that when available, monolithic devices replace their hybrid counterparts. The situation with RF isolation technology replacing optocoupler technology is no different. We are taking a difficult function, simplifying the implementation so it looks like any other CMOS device that we're used to, and then allowing you to use that in your product in a much more straightforward way than an optocoupler. The use of digital isolation technology then offers a number of advantages for our customers. Multi-channel isolation solutions, isolated gate drivers, higher service life or longer service life, increased reliability, and more. The key advantages Silicon Labs digital isolation technology has over optocouplers are no aging or performance degradation over time, increased system reliability due to a 10 times lower failure rate, 2 times better noise immunity, and wider temperature range from -40 to 125 degrees centigrade. For more information on how Silicon Labs digital isolation technology can improve your system design, please go to our website, www.silabs.com/isolation, and download a free copy of our
Features of a Gigabit digital isolator. The ADN4654 is a Gigabit digital isolator, and its features are 1.1 gigabit per second data rate, is a dual channel and multiple channel option, support 5 kV RMS or 3.75 kV RMS with a stand voltage. It's the first Gigabit digital isolators and isolate high-speed serial directly without serialization, including video. They are fully integrated compact IC solution, unlike fiber or discrete alternative custom design. Pros and cons. Pros: faster than the octocouplers, low power emission at low frequency, 1 gigabit per second possible, noise immune, low emission even at high frequency. The cons: the main big reason is to accept the value of the manufacturer specification. Now I present a video about immune digital isolation and is immune to the noise.
Real-world harsh environments are tricky to replicate. Test with direct power injection to ensure the highest level of noise immunity for your isolated system. To ensure the integrity of the data as it crosses the isolation barrier, the system must be immune to noise at all frequencies, even up to 1 gigahertz. CMTI is one method for measuring noise immunity of digital isolators, but trapezoidal waveforms are frequency limited and decrease in amplitude significantly above 100 megahertz. With digital isolators used in a range of applications, it's important to ensure the data is immune to real-world transient events. The results of your DPI testing are only as good as your setup. Ensure that you have the proper equipment and that you've paid attention to your grounding and power. Testing to failure at each frequency demonstrates how well your system will perform in the real world. For more information on EMC testing and analog devices digital isolation, please visit analog.com/iCoupler.
Application. Data isolators are most used with isolate power supplies in separate ground, which is also useful in preventing ground interference and noise current from power supplies. Also is used in communication isolation, industrial field bus isolation, and general purpose multi-channel isolation. Now I present a video about models of digital isolators.
Hi, my name is Mark Cantrell. I'm an applications engineer with the isolation group here at Analog Devices. Today we're going to be talking about three of our new iCoupler products that include IsoPower. For more information on these products, you can go to our website at www.analog.com/iCoupler. Isolation provides a safety barrier for people and a noise barrier for instrumentation. The problem has been that once you transfer data to the secondary, you also have to get power to the secondary in order to run the interface. This has traditionally been done with either isolated DC-DC converters or offline AC-DC converters. These can be big, expensive, and hard to get certified. ADI has leveraged their microtransformer technology developed for the iCoupler to create the world's smallest UL certified DC-DC converter, and we can build it right into our new iCoupler products, making ISO power devices. The ADUM 5000 is a power only module. It includes no data channels. The ADUM 52OX is a 2-channel data module. Each channel can run up to 25 megabits per second. The ADUM 540X includes 4 data channels. Each can run up to 25 megabits per second. All of these modules are able to make 3 volts or 5 volt power from a 3 volt or 5 volt source. For simplicity, let's focus on the ADUM 5000 since it's the power supply only module and we're focusing on that aspect of our products today. The way that our DC-DC converters work is we have a very high frequency, 180 megahertz input oscillator that switches current into our microtransformers. This high frequency is required in order to get good transfer across these tiny coils. The signal is then received at the secondary where it's rectified and sent into a regulation control circuit. The regulation control circuit creates a PWM style pulse which is sent back through a dedicated iCoupler channel to the primary where it modulates the oscillator on and off to control the output voltage. The set points can be selected by the customer to either be 3.3 or 5 volts. Here we have a cutaway of our SO16 wide package containing the 4 die that make up a standard ISO power iCoupler. You see here are the 2 large coils used for the power transformer. Below them is the feedback iCoupler channel, which provides the PWM signal from the secondary to the primary. These other coils down here are actually the 4 channels for one of our quad iCoupler devices. The oscillator and the rectifier and control circuits are all built onto a standard silicon die shown here, and the entire structure is wire bonded together in a package. If we look at the actual currents and voltages inside the part, there are 2 main signal paths that we need to worry about. One is the actual current going through the transformer, which is made of bursts of 5.6 nanosecond pulses to go through the small transformers. These are under the control of the regulation control signal coming from the regulator on the secondary side. I have the scope set up to actually look at a regulation control signal from our ADUM 5000 part on this demo board. And as you can see, as I change the load, the PWM changes the on time for the oscillator and hence the power to the secondary. Moving back to the block diagram of the ADUM 5000, we can see that this regulation control signal gives us a great deal of flexibility in how we can handle power, because we can take that RC out, or that regulation control, and provide it to the outside world to the RC out pin, which allows this device to act as a master controlling other iCouplers with ISO power. We can also accept a regulation control signal from an external device, allowing this to become a slave to another device. This gives us a great deal of flexibility in combining these devices at the secondary side.
For conclusion, digital isolators bring many advantages over optocouplers, since optocoupler, although incorporated in many designs, are based on outdated LED technology that provides significant output variation over input current, temperature, and age. This reduces performance over the device lifetime. Digital isolation components easily provide multi-channel isolation solutions with a much smaller footprint. Increased system reliability due to a lower failure rate, offer twice the electrical noise immunity, operate over a wider temperature range, and do not age or degrade over time. The use of this device depends on the type of technology you want to use and its availability. Thank you.